Optical illusions are fascinating. They are like puzzles for our brains. They make us question what we see and how we see it. From simple geometric shapes to complex images, optical illusions can trick our perception. They reveal the intricate workings of our visual system.
Optical illusions have captivated people for centuries. Ancient civilizations incorporated them into their art and architecture. Today, scientists and artists continue to explore the power of illusions. They use them to study perception, create stunning visuals, and even enhance our understanding of the brain.
These visual tricks demonstrate that seeing is not always believing. Our eyes may capture an image, but it is our brain that interprets it. This interpretation is based on our experiences, expectations, and the way our brains are wired. Join me as we delve into the fascinating world of optical illusions. Our brains are incredible organs capable of performing countless functions simultaneously. They constantly process information from our senses, integrating data from sight, sound, touch, taste, and smell. Vision is one of our most important senses, providing us with the majority of the information we use to understand our surroundings. It allows us to navigate the world, recognize objects, and perceive depth and motion, making it essential for daily life.
When light enters our eyes, it hits the retina at the back of the eye, initiating the process of vision. The retina contains special cells called photoreceptors, which are crucial for converting light into signals. These photoreceptors convert light into electrical signals, a process that is fundamental to vision. These signals travel through the optic nerve to the brain, where they are further processed. The brain then processes these signals, interpreting them to form a coherent image of our environment. It combines them with our prior knowledge and experiences to create a detailed representation of the world around us. This process is incredibly complex and involves multiple areas of the brain, each contributing to different aspects of vision. However, our brains can be fooled by visual tricks and illusions. Optical illusions exploit the shortcuts and assumptions that our brains make during visual processing, revealing the brain's inner workings. By understanding these shortcuts, we can gain a deeper appreciation for the complexity of human vision and the remarkable capabilities of our brains.
Optical illusions can be broadly categorized into three types: literal, physiological, and cognitive. These categories help us understand the different mechanisms behind how our brains perceive and sometimes misinterpret visual information. Each type tricks our brains in different ways, creating fascinating experiences that challenge our perception of reality.
Literal illusions create images that are different from the objects that make them. These illusions often involve straightforward visual tricks that can be easily explained by the properties of light and perspective. For example, a straw in a glass of water appears bent due to the refraction of light. This bending effect occurs because light travels at different speeds in air and water, causing the light rays to change direction. Physiological illusions, on the other hand, are caused by the overstimulation of our visual system. These illusions often result from the intense or prolonged exposure to certain visual stimuli, leading to temporary changes in perception. The Hermann grid illusion, where we see gray dots at the intersections of a white grid on a black background, is a classic example of this type. This illusion occurs due to the way our retinal cells respond to contrasting light and dark areas. Cognitive illusions exploit the way our brains interpret information. These illusions often involve higher-level cognitive processes, such as attention, memory, and expectation. The Ames room illusion, where people appear to shrink or grow as they walk across a room, is a prime example of a cognitive illusion. This illusion plays on our brain's assumptions about the geometry of the room, leading to a distorted perception of size and distance.
By understanding the different types of illusions, we gain insight into the complex processes that govern our visual perception. We can better appreciate the various ways in which our brains can be tricked, and how these tricks reveal the intricate workings of our visual and cognitive systems. The Ames room illusion is a fascinating example of a cognitive illusion. It was invented by American ophthalmologist Adelbert Ames Jr. in 1934. The illusion uses a distorted room to create a visual illusion. The room is constructed so that it appears to be a normal rectangular room when viewed from a specific vantage point. However, the room's shape is actually trapezoidal. The walls are slanted, and the floor and ceiling are at an incline.
When people walk from one corner of the room to the other, they appear to shrink or grow in size. This illusion occurs because our brains assume that the room is rectangular. Based on this assumption, our brains interpret the changing size of the person as a change in height. The Ames room illusion demonstrates how our brains can be tricked by manipulating our perception of perspective and depth.
Tricking the brain: how illusions exploit our perception.
Optical illusions work by exploiting the way our brains process visual information.
Our brains use a variety of shortcuts and assumptions to make sense of the world around us.
These shortcuts are usually helpful, allowing us to process information quickly and efficiently.
For example, our brains assume that light travels in straight lines.
This assumption helps us to perceive depth and distance. However, this assumption can also lead to illusions when light is bent or refracted.
Our brains also tend to fill in missing information based on our prior experiences.
This process, known as perceptual filling in, can lead to illusions when our brains fill in information that is not actually present.
By understanding the shortcuts and assumptions that our brains make, we can better understand how optical illusions work.
Section 6. The Hermann Grid. Illusions seeing spots that aren't there. The Hermann grid illusion is a classic example of a physiological illusion, which tricks our visual system into seeing something that isn't actually there. It was first described by German physiologist Ludimar Hermann in 1870, making it one of the oldest documented optical illusions. The illusion consists of a grid of black squares on a white background, with the intersections of the grid lines being the focal point of the illusion.
When you look at the grid, you may notice grey dots appearing at the intersections of the grid lines. These dots seem to flicker in and out of existence. However, if you look directly at a dot, it disappears, making the illusion even more intriguing. The dots seem to appear in your peripheral vision, but vanish when you focus on them, creating a dynamic visual experience.
The Hermann grid illusion is thought to be caused by the lateral inhibition of neurons in the retina, a fundamental process in our visual system. Lateral inhibition is the process by which activated neurons inhibit the activity of their neighbors, enhancing the contrast between light and dark areas. This process helps to enhance contrast and edge detection, which are crucial for our ability to perceive the world around us clearly. In the Hermann grid illusion, the neurons at the intersections of the grid lines are inhibited by the surrounding neurons, leading to the perception of grey dots. This inhibition results in a decrease in neural activity at the intersections, which is perceived by our brain as a grey dot. This fascinating interplay of neural activity and perception showcases the complexity of our visual system. Section 7. Illusions in the real world, from art to architecture. Optical illusions are not just limited to textbooks and science museums. They are all around us, from art and architecture to nature and everyday life.
Artists have long used optical illusions to create stunning visual effects. For example, the Dutch artist M.C. Escher was famous for his mind-bending lithographs that played with perspective and geometry. His works often featured impossible objects and staircases that seemed to ascend and descend endlessly.
Architects also use optical illusions to create a sense of space, depth, and grandeur. For example, the Parthenon in Greece incorporates subtle optical illusions to make it appear more symmetrical and imposing than it actually is. The columns are slightly wider at the base and taper towards the top, creating an illusion of height and stability. Section 8. The importance of illusions. Understanding our brains. Optical illusions are more than just amusing diversions. They are valuable tools for scientists and psychologists studying human perception, cognition, and neurology.
By studying how our brains process illusions, researchers can gain insights into the complex workings of our visual system. Illusions can also be used to diagnose and treat visual impairments. For example, the Ishihara color test, which uses patterns of colored dots to detect color blindness, is a well-known example of an illusion used in clinical practice.
Moreover, understanding optical illusions can help us to be more aware of the limitations of our own perception. By recognizing that our brains can be tricked, we can learn to be more critical thinkers and to question what we see. Section 9. Conclusion: the never-ending fascination with illusions. Optical illusions continue to fascinate and intrigue us. They are a testament to the incredible power and adaptability of the human brain.
By studying illusions, we gain a deeper appreciation for the complexity of our visual system and the many factors that influence our perception. From simple geometric patterns to complex three-dimensional images, optical illusions offer a window into the hidden workings of our minds.
They remind us that seeing is not always believing, and that our brains are constantly striving to make sense of the world around us. So the next time you encounter an optical illusion, take a moment to appreciate the wonder and complexity of your own perception. Ask yourself, how did my brain create this illusion? And what does this tell me about how I see